The slides, don't interrupt me. The slides are for today, September 2nd. You guys, first hour, are the only class that I'm actually present in and teaching the lesson to. And then I am providing the lesson to the rest of my other classes. So the slides look a little weird. That's because they're set for the rest of my classes so that they know what to do. So anytime I am ever absent, you should be looking to Schoology for what you're supposed to do, regardless of what is in class. Like even though I wrote on the board that the video lesson and to-do list is in Schoology in the September 2nd slides, clearly no one had any idea what they were supposed to do. All right, the expectation is you check Schoology, click on today's date, read the instructions in the slides, like what is displayed on here. So everyone is to complete the following, even you guys, even though I'm here for the lesson. I guess the only exception is that you guys don't have to watch the video lesson because you're here, but you do need to take notes on the provided note sheet and submit a picture of your notes into the assignment link in Schoology. And then still save your notes for binder check number 2. Then you will complete the practice in Schoology. So we are now in unit 2. Today is lesson 1. It's called Planning a Pizza Party. So the goal is to write expressions to estimate the cost of a pizza party. And you'll know that you are successful if you can explain the meaning of the term constraints, if you can tell which quantities in a situation can vary and which ones cannot, and if you can use letters and numbers to write expressions representing the quantities in a situation. So all of these 3 things you need to be successful. I'm recording right now. I'll link it in the slides. This is where anyone who's absent would come to watch the lesson. And this is where everyone else today will come to watch the lesson. So regardless of whether I'm here or not, I always leave something for you. So that's what the rest of the classes are required to do. This link is where you'll submit your note sheet, including you guys. So make sure you do that because that's how I hold you accountable, really mostly for my other classes, but still making you guys do it too, which should be an easy classwork grade. And then the puzzle piece in Schoology called Unit 2, Lesson 1. The binder check is past due. You can still turn it in up until, because I try to give you like about a 4-week grading period. So this coming end of grading period is the last time you can turn in that binder check. So some of you have low grades in it. Some of you have a 0 because you didn't have it on the day that I asked for it, or some of you are absent. So make sure that if that applies to you, that you show it to me at some point, not like right in the middle of me teaching, but that it's on you now to make sure that you are submitting that to me. You can also turn them in on Schoology if you want. Like I had someone who turned in to me like a video of them flipping through their binder. Perfect. But of course, you can also show me in class as long as I'm not in the middle of teaching. Deadline for late work from the blue folders is today. So anything from unit 1 that you still need to do is due by today. I would suggest making sure that your study guide is completely done first, since that's worth the biggest chunk of points. And then follow that up with any other missing assignments that you want credit for. So questions, comments, concerns? All right, so then to the warm-up. Here are some letters and what they represent. All costs are in dollars. So then you should have answered these on your paper. Now discuss with the partner, what does each equation mean in this situation? I'll give you 1 minute. I know you need to close one. And I think I need to unlock it for you too. There's the phone. All right, So what would M equals 7.50 mean? What does that represent?
Here's what I found.
Okay, Lauren. So the main dish costs $7.50. You may have said that, but you were very quiet, whoever said that, so I needed a louder voice. All right, the main dish costs $7.50. What does M equals S plus 4.50 equal? Caitlin? So a main dish, what'd you say? So a main dish is $4.50 more than a side dish. Good. What about part C? Riley? Let's see. Not necessarily. Not necessarily. It's not saying that there's 6 side dishes. Alex?
The cost of one side dish is C.
But what is it doing to the S? Multiplying, therefore, Daniel?
The number of side dishes multiplied by the cost of the side dish.
So yes, let me kind of clean that up a little bit. It's ordering N side dishes. And we don't know what N equals other than number of side dishes, but ordering N side dishes at S dollars each, because that's the cost of a side dish. So at S dollars each costs $6. Again, we don't know specifically what N and S equal, but we know that when they're multiplied together, it equals $6. So N side dishes at S dollars each cost $6 total. All right, and the last one. M plus NS equals T. Lauren. Good. So we have the cost of a main dish, which is what M equals, plus the N side dishes at S dollars each. I should say at. Equal the total amount of the meal. All right, that's a lot of words for just this little equation, isn't it? All right, so that's why we use, these variables to represent certain things, so that we don't have to say what's the cost of a main dish plus N side dishes at S dollars each to give me the total amount. All right, no, we could just say M plus NS equals T. All right, and then the last part was a little trickier, I guess you could say. It says write a new equation that could be true in this situation. Anyone come up with anything? Yes, Lauren? N equals M minus 450. Good. Because a main dish is 450 more than a side dish. So a side dish is n minus 450, yes?
Then wouldn't it be S equals N minus 450? Because that is the number.
Oh, you're right. You are correct. Good catch. Glad I have you guys here and that I record in this class. Because yeah, we haven't learned how to solve equations yet. But if I want to get the S by itself, I would have to subtract $4.50 from each side, which is how you get this equation down here. Anything else someone came up with? Yes, Caitlin? $7.50 plus $6, you said? Equals $13.50. So good, replacing the variables with the numbers that they actually equal. Anything else? All right, those are actually really good. Here's a couple others from the book if you want to write them down. We have m plus 6 equals 13.5. Again, replacing the 750 with the m. I have m minus s equals 4.5. But what you guys gave me is a great example as well. I'm actually gonna write those down for the future in case we can't come up with anything. All right, so what does an equation tell us? First of all, what is an equation? Yes? It is a mathematical sentence. It has to contain what? It could contain variables, it could contain numbers, it would follow order of operations, but there's something specific that equations have to have. Equal sign, good. Mathematical sentences with equal sign. It's like in the first part of the word equation. Equal. So it needs an equal sign. Otherwise, then it's just an expression. What do, and this, there is a part for you to write that. If you look on your note sheet where it says, let's look at, right next to the warm up. An equation is mathematical sentences with equal signs. Yes. Good. So what would you put for what's an expression? Perfect. Expressions are mathematical sentences without equal signs. All right. So if I had like just m plus 6, it's nothing equal to it, that would be an expression. But then once I do m plus 6 equals 13.5, now it's an equation. All right, so then what do equations tell us? Yes. They have numbers and variables. You could actually put that in one of your notes where it says equations and expressions, numbers, variables. And what do those numbers and variables usually represent? Well, the variables do represent other numbers, yes. Items, objects, like real world scenarios. So, I mean, I know you don't use like certain formulas yet in science, unless, I don't know, if you're in an advanced science class, but like there's formulas for calculating velocity. There's formulas for calculating density, so like each part like measures something and is used in the real world. Let's see. I don't want to drag this on. I also want to give you time. So imagine your class is having a pizza party. Let me make this smaller so you can see it on the screen. Work with your group to plan what to order and to estimate what the party would cost. Record your group's plan and cost estimate. What would it take to convince the class to go with your group's plan? Be prepared to explain your reasoning, like how many pizzas would you need? A large pizza costs $12, and so forth. So I'll give you. Yes, well, I mean, we'll go through them too, but I'll give you like 2 minutes to discuss what you would need for a pizza party for this class. And write it on your notes if there's a spot. No. So what are some things that we need to consider to correctly plan this pizza party? Yes, Alex. Okay, how many slices in a pizza? Yes, Lauren? How many people in the class? Not yet. Yes, Gavin? How much do the pizzas cost? Is that what you said? How many total pizzas we need? Anything else? Yes?
Not aligned.
What do you think would be a decent amount of like pizza slices per person? So that's something we would have to establish also, like how many slices per person?
Yeah. 62. And then 12, because it's 12, like.
All right, so listen, voices. How many people are in this class today? Did you count?
31.
Well, then Gianna came in, so how many is that?
31.
And what about me? Don't I get some people?
Yeah, I said 30. Well, you get your pizza now.
Well, then I'm really not contributing to this pizza party. All right, but there's 33 people. About how many total, listen, stop talking over me. About how many slices are there usually, say like in a large pizza as a thing?
8 is like a small pizza.
12 is another 4.
8 is.
Okay, let's stop calling out. All right, it says that a large pizza costs $12. So then if they each have about like 12 slices, how many would we need?
Like, oh, yeah, like, that's literally. I did the math. You heard one by one. I did the math. You tried to round down. You tried to round
So
down.
let's continue answering these questions. Stop calling out. I know it's fun. All right, we're having fun, but like, we need to also have time to practice. Stop talking. What did I just say? All right. So figuring out how many pizzas we need. There's 33 total in this class. How many slices do we need if each person's gonna have 2? So then if each pizza has about 12 slices, what are we gonna do to figure out how many we need? We're going to divide. What's 66 divided by 12?
Not 5 to 5.
Let's just round it.
It is 5.5. Do they sell half a pizza
No,
ever?
they're round it.
Round two.
But they didn't give us the price for the small.
So then we need 6 large pizzas. Is there a place for you to write how many pizzas we need?
At the back. On
What?
We're on that.
in the back.
Oh, no.
In the back.
No, no, you can write that. You can write.
And then if a large pizza costs $12 and we need 6 of them, how much is that going to cost?
I can.
What operation would you do to do that? So 6 times 12 is 72. It says write down 1 or more expressions that show how your group's cost estimate was calculated. So here's an example it looks like, but we're not that example. What operations did we do? We did
Multiplication division.
66 divided by 12. And 12 represented how many slices in a pizza, right? If we had to assign it a variable, what could we assign it? S for slices, sure. So we could even do 66 divided by S. For how many people are in this class, I mean, that we kind of don't need an expression for, we just had to count. But then we had to figure out how many slices we wanted to give each person. So if we definitely agreed on 2 per person, how could we assign the 33 a variable? What letter? P for people. So 2 times P is what we did to figure out that we needed 66 slices. Make sense? So there's some examples of expressions we could have used. And then we could also even, since the 2P equaled 66, and now that's an equation, not an expression. But we know that 2P equaled 66, we could even make this expression. 2P divided by S. And what did that end up equaling? We had the 5.5. What did that represent? Well, no, that's not what it represented.
Amount of pizzas.
How many total pizzas? What letter do you want to give that?
PP.
You have to give it 1 letter, not multiple. We'll go in T because P was already used. Right? So we could even make this equal to T. All right, remember what each one represented? This is the formula for planning our pizza party. So in your expressions, are there quantities that might change on the day of the party?
Yeah.
Which ones might
The
change?
amount of people. Because when people might show up.
Number of people, which was represented by what letter? What else could change? Yes, Lauren?
Not everyone will also go, but not everyone wants to.
So not everyone may have 2 slices. Maybe some people forgot and had breakfast and now they're not hungry anymore. Yes,
Like people are gone and also that you have to give them the pizzas.
maybe not as many pizzas. So like number of pizzas, maybe more people show up and then we have to order more. Who knows? All right, and then it says rewrite your expressions, replacing the quantities that might change with letters. We kind of already did that, didn't we? Yeah, so we'll skip that one, but just know, like, once you establish what something represents, you can assign it a variable and then put it into an expression. We definitely agreed that we needed 2 slices per person. We could even assign that a variable if we want And then we have all these moving parts now that could change the way we plan our pizza party. Good. Now, what are constraints? Let's see if there's a spot for you to write this somewhere. Is there? It's actually on the back side of your page that says constraints. And there's blanks for you to fill in. Everyone see it? Back side of your note page, very top.
Oh, okay.
So fill in the blanks. Constraints is something that limits, so fill in that blank, what is possible or reasonable in a situation. Question? Change that to constraints. That was probably an oversight. Because clearly the word is constraints, not constants. Should be a constraint. And that's one of our learning targets, is to know what a constraint is. So something that limits what is possible or reasonable in a situation. So for example, one constraint in a pizza party might be the number of slices of pizza each person could have. We can write S less than 4 to say that each person gets fewer than 4 slices. So can they have exactly 4 slices then? Fewer. So most they could have is 3. Look at the expressions you wrote when planning the pizza party earlier. Choose an expression that uses one or more letters. For each letter, determine what values would be reasonable. So the letters we had were S, P, T. Okay, well then, let's think about it. Not everything has to be written down. Is there some? So toward the bottom of your note sheet, it says, what are the constraints? You could just jot it and mark them there. Constant is constraint. All right, so for each letter, determine what would be reasonable. Do that on your own for a second and we'll discuss. Somewhere on my note sheet, it really doesn't matter. Sorry, I just keep saying the same thing and like,
No,
you guys keep
okay.
asking the same question. Like, stop, listen the first time. Question? Yes. All right, so for the number of slices, what constraints did we have? Any? What did we discuss they could have in our situation? Good, you could say S less than 3. What's another way we could say they could have 2 or less?
Is. Or
Well, we don't want them to have 3. We want them to have how many? A max.
okay, so less than or equal to 2.
Perfect. Both of these say the same thing. But I kind of lean more toward the bottom one because less than 3 could be like 2.5, right? And do we want someone to have 2.5 slices? No, we want it to be whole numbers, right? So we could say whole numbers less than 3 if we really wanted to. Questions on that one? Now remember, the P represented people. So what are some constraints that we have for people? Like, could we have a non-whole number for people?
Yes.
Can we have a fraction of a person?
I mean, I think I.
So whole number, they have to be whole numbers. Do we have classes that are super large at this school?
Yeah.
What's like the largest class you have?
This is like,
Number of people in that class, Bob.
I don't know, maybe
So we'd want to have no p values that are greater than, I don't know, 40. Anyone have a class size of 40? So if we want to put that the p has to be like non-reasonable, like unreasonable, what should we put for that expression?
E is less than or equal to, like, 4.
Perfect. So most that we will be serving is 40 people. You can also put p less than 41, I suppose, but again, it would have to be equal numbers. Can it be a negative number?
No.
No, you can't have a negative number of people. All right, the T represented total number of pizzas, right? So then what would be reasonable? Can we have non-whole numbers? They would have to be whole numbers again, 'cause can you buy a fraction of a pizza? Not usually, no. Can it be a really big value? What's like an unreasonable value?
50.
50 pizzas, like we shouldn't have more than 50 pizzas. So I guess you could put a constraint on that. What constraint do you want to put?
E is less than 50, because we shouldn't even have 50.
I still think 50 is pretty big, but that's what you want to go with.
No, it shouldn't be less than 40. It needs to be less than.
Okay, yeah. Good. And then can we have a negative number of pizzas?
No.
So it has to be, again, whole numbers, which are supposed to be positive, I'm pretty sure, but we could also put that it has to be positive numbers. Those are examples of constraints. Questions, comments, concerns? All right, and that's what we did. We did this part right here off to the side. So write equations and inequalities that represent some constraints in your pizza party plan. If a quantity must be an exact value, use the equal sign. Or in our case, greater than. Okay, great, put it in the. Questions on that? All right, I do want you to have time to work on your practice. Let's look at the cool down real quick. Stop talking while I am talking, for the love. We have a cool down. Once we're done, then you get time to work. So as a reward for achieving their goals, all students in the 9th grade are invited to an ice cream party. Write an expression that could represent an estimated cost for the party. Use at least one letter. And then say what it represents. There's a part on your note sheet for the time where it says cool down. Choose a letter in your expression. Describe the values that would be reasonable for the quantity that the letter represents. Good, any questions? All right. I'll give you 2 minutes, be prepared to share. So for the first part, what expression did you guys use to represent the cost for an ice cream party? Lauren? Well, it's kind of both. Less than or equal to 10, what? Okay, 10 tubs of ice cream. All right. That is an inequality. I know we haven't gone to inequalities really, but expressions don't have equal signs or necessarily inequality symbols. So that is a good attempt. It could still represent aspects of your ice cream party. In fact, I'll probably put it down here because we're describing values that would be reasonable for the quantity that the letter represents. So we're saying like I stands for what? So I for ice cream should be less than or equal to 10. And I'm actually going to make that ice cream tubs and then erase that T. So I will be for ice cream tubs should be less than or equal to 10. All right, who can give me an expression that would represent the estimated cost for the ice cream party? Yes, Amir? So that's another example of a constraint where C must be greater than 100. What do you have C representing? All right, C for cost. What would you like account for in an ice cream party? Number of students, do we know the number of students in the ninth grade? So maybe we could make that as N, where N is number of students. And what would we do with the number of students? Would we add it to something, multiply it, divide it? Divide it by what? Well, how much ice cream would each person get? We could do scoops. How many scoops of ice cream would we give each person? So we could say S for scoops. And if I want to know like the number of total scoops that I need, what would I do with these two variables? Would I add them, subtract them, multiply them? Multiply them. So NS could be an answer to number 1. That's an example of an expression that would give me part of the estimated cost. What else do we need to know to find the estimated cost? Do we know how many scoops of ice cream are in one ice cream tub? So that would be something we need to figure out. So we could do, remember I was for ice cream tubs. How would we figure out how many servings we have? Well, we need to know how many scoops are in an ice cream tub. We don't know that, so that's why it's an S. So we could say I divided by the number of scoops gives me the total number of servings. All right, it's supposed to be an expression, but that's what this expression is representing. Anyone have an expression to tell me the cost of the ice cream party? All right, well, what about number of servings times like the cost of the ice cream? How much each ice cream costs? So number of students times the cost of the ice cream. All right, there's lots of things that you could put there. All right, so we'll end it there. Sorry, that basically took the whole hour.